tragic death of a 16-year-old boy in Florida, found near an electrified bus bench, has brought to light the critical importance of proper electrical work and safety measures. The bench, owned by the county, was determined to be energized due to faulty wiring and a complete lack of grounding. The investigation revealed that an unlicensed electrician had miswired the bench. Specifically, a wire from the secondary of a sign ballast was in direct contact with the metal frame of the bench. This contact, combined with the absence of a grounding system, allowed the electricity to flow freely through the bench, turning it into a deadly conductor. Grounding is a fundamental safety practice in electrical systems. Its primary purpose is to provide a low-resistance path for fault currents to return to the source. In a properly grounded system, if a live wire comes into contact with a metal enclosure or any conductive surface, the fault current will immediately flow to ground. This high current flow will then trip a circuit breaker or blow a fuse, cutting off the power and preventing electric shock. Without grounding, the metal parts of electrical equipment can become energized, posing a significant risk of electrocution. The National Electrical Code, or NEC, provides comprehensive guidelines for grounding electrical systems. These guidelines cover various aspects, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the requirements for bonding metal parts. Bonding refers to the practice of connecting all metal parts of an electrical system together to create a continuous conductive path. This ensures that all metal parts are at the same electrical potential, minimizing the risk of voltage differences that could cause electric shock. In this particular case, the absence of grounding and the presence of a miswired sign ballast created a lethal combination. The sign ballast, which is responsible for regulating the voltage and current to the sign's lighting, can produce a high voltage on its secondary side. When a wire from the secondary side came into contact with the ungrounded bench frame, the frame became energized with a potentially lethal voltage. The fact that the installing company did not obtain a permit or inspection for the work is also a significant concern. Permits and inspections are essential for ensuring that electrical work is performed safely and in accordance with the NEC. Inspectors can identify potential hazards and ensure that the work meets the required standards. The company's claim that the death was caused by a lightning strike is highly questionable. While lightning strikes can certainly be dangerous, investigators have found clear evidence of faulty wiring and lack of grounding, which are far more likely to have been the cause of the electrocution. Let's discuss electrical safety in more detail, covering aspects like grounding, bonding, and the role of safety devices like ground fault circuit interrupters, also known as GFCIs. Grounding serves as a critical safety measure by providing a lower impedance path for fault current to return to the source, thereby tripping over current protection devices like circuit breakers or fuses. This rapid interruption of power prevents dangerous voltage buildup on equipment enclosures and reduces the risk of electric shock. Bonding, closely related to grounding, involves connecting all metallic parts of an electrical system to create an electrically continuous path. This ensures that all bonded components are at the same electrical potential, minimizing voltage differences that could pose a shock hazard. Ground fault circuit interrupters, GFCIs, are another essential safety device designed to protect against electric shock. They work by monitoring the current flowing in the circuit and quickly interrupting the power if a ground fault is detected. A ground fault occurs when current leaks from a live conductor to ground, often through a person's body. GFCIs are particularly important in areas where there is a high risk of exposure to moisture, such as bathrooms, kitchens, and outdoor locations. To further elaborate on grounding, there are different types of grounding systems commonly used. These include equipment grounding and system grounding. Equipment grounding connects the non-current carrying metal parts of electrical equipment to ground, providing a path for fault current. System grounding, on the other hand, connects the neutral point of the electrical supply system to ground, stabilizing the voltage and providing a reference point for the system. The NEC, or National Electrical Code, provides detailed requirements for grounding and bonding electrical systems. These requirements cover conductor sizing, installation methods, and the types of equipment that must be grounded. Adhering to the NEC guidelines is crucial for ensuring the safety and reliability of electrical installations. Regarding bonding, it's essential to understand the different types of bonding techniques. These include direct bonding, where metal parts are directly connected using conductors or bonding jumpers, and indirect bonding, where metal parts are bonded through a common grounding electrode. The choice of bonding method depends on the specific application and the requirements of the NEC. The NEC also specifies the minimum size of bonding conductors based on the size of the circuit conductors. Proper bonding ensures that all metal parts are at the same electrical potential, reducing the risk of shock hazards. Furthermore, let's delve deeper into the workings of GFCIs and their importance in preventing electrical injuries. GFCIs operate on the principle of detecting imbalances in the current flowing through the hot and neutral conductors of a circuit. Under normal conditions, the current flowing through the hot conductor should be equal to the current flowing through the neutral conductor. However, if a ground fault occurs, some of the current will leak to ground, creating an imbalance. The GFCI detects this imbalance and quickly trips the circuit, interrupting the power and preventing electric shock. GFCIs are designed to trip within a fraction of a second, typically within 20 to 30 milliseconds, which is fast enough to prevent serious injury. They are required by the NEC in many locations, including bathrooms, kitchens, outdoor receptacles, and construction sites. Testing GFCIs regularly is crucial to ensure that they are functioning properly. Most GFCIs have a test button that simulates a ground fault, allowing you to verify that the device is tripping as intended. It's recommended to test GFCIs at least once a month. In addition to grounding, bonding, and GFCIs, other safety devices can help protect against electrical hazards. These include arc fault circuit interrupters, or RFCIs, which detect dangerous arcing faults in electrical wiring, and surge protective devices, or SPDs, which protect against voltage surges caused by lightning or other events. RFCIs work by monitoring the current waveform in a circuit and detecting the telltale signs of an arc fault, such as erratic current fluctuations and high-frequency noise. When an arc fault is detected, the RFCI trips the circuit, preventing a fire from starting. SPD protect against voltage surges by diverting excess voltage to ground, preventing damage to sensitive electronic equipment. They are often installed at the service entrance of a building to protect the entire electrical system. Electrical safety is not just the responsibility of electricians and contractors. It's also important for homeowners and building occupants to be aware of potential electrical hazards and take steps to prevent accidents. Some basic electrical safety tips include avoiding overloading electrical circuits, using extension cords safely, and never touching electrical equipment with wet hands. Overloading circuits can cause the wires to overheat, increasing the risk of fire. Avoid plugging too many appliances into a single circuit. When using extension cords, make sure they are properly rated for the intended use and that they are not damaged. Never run extension cords under rugs or furniture, as this can trap heat and create a fire hazard. Always keep electrical equipment away from water and never touch electrical equipment with wet hands. Water is a good conductor of electricity, and touching electrical equipment with wet hands can increase the risk of electric shock. If you are not comfortable working with electricity, always hire a qualified electrician to perform electrical repairs or installations. Working with electricity can be dangerous, and it's important to have the necessary knowledge and skills to do the job safely. In the case of the bus bench electrocution, it is likely that a combination of factors contributed to the tragedy. The lack of grounding, the miswired sign ballast, and the absence of permits and inspections all played a role in creating a dangerous situation. It's a stark reminder of the importance of following electrical safety codes and best practices to prevent future accidents. Firstly, ensure all electrical work is performed by qualified and licensed electricians. Secondly, always obtain the necessary permits and inspections for electrical work. Thirdly, regularly inspect electrical systems for potential hazards. Fourthly, install and test GFCIs in areas where there is a high risk of exposure to moisture. Fifthly, educate yourself and others about electrical safety. Sixthly, never attempt electrical repairs or installations if you are not qualified. Seventhly, always disconnect power before working on electrical equipment. Eighthly, use appropriate safety equipment, such as insulated gloves and tools. Ninthly, report any electrical hazards to the appropriate authorities. Tenthly, stay vigilant and proactive in promoting electrical safety. Proper training and licensing are essential for electricians. They ensure that electricians have the knowledge and skills to perform electrical work safely and in accordance with the NEC. Licensing also provides a mechanism for holding electricians accountable for their work. Permits and inspections are another important layer of protection. They ensure that electrical work is reviewed by qualified inspectors who can identify potential hazards and ensure that the work meets the required standards. Regular inspections of electrical systems can help identify potential problems before they lead to accidents. Look for signs of damage, such as frayed wires, cracked insulation, and loose connections. Addressing these problems promptly can prevent more serious issues from developing. Ground fault circuit interrupters, as mentioned earlier, are crucial for protecting against electric shock. They should be installed in all areas where there is a high risk of exposure to moisture. Education is also key to preventing electrical accidents. Educate yourself and others about the dangers of electricity and the steps that can be taken to prevent accidents. This includes teaching children about electrical safety and providing training for workers who may be exposed to electrical hazards. If you are not comfortable working with electricity, always hire a qualified electrician to perform electrical repairs or installations. Attempting to do electrical work yourself can be dangerous and may void your insurance coverage. Before working on any electrical equipment, always disconnect the power at the circuit breaker or fuse box. This will prevent you from accidentally coming into contact with live wires. Use appropriate safety equipment when working with electricity, such as insulated gloves and tools. This will help protect you from electric shock. Report any electrical hazards to the appropriate authorities, such as your local building department or utility company. This will help ensure that the hazards are addressed promptly and that others are not put at risk. By following these safety tips, you can help prevent electrical accidents and protect yourself and others from harm. The death of the 16-year-old boy serves as a somber reminder of the potential consequences of neglecting electrical safety. It underscores the importance of adhering to established codes, employing qualified professionals, and promoting a culture of safety in all aspects of electrical work.